Okay, welcome to the third and fourth practicals of Object-Oriented Programming 1. Thank you for being here, even if today is no lecture, just practicals. There are not as many people as last time, but still, thank you for being here. Yeah, and as you may notice, we are not teaching this practicals alone. We also have Thomas and Daniel, which will talk about two topics of today. So let's directly see what's happening today. The second last time in the lecture you saw inheritance, and I think last time you also talked about polymorphism. These two topics are closely related to each other, and we will present an exhaustive example on it. So we try really to show you every case that may happen during coding and demonstrate what happens there. And then Daniel will speak about STD map. So this is a data structure similar to the STD vector, but with some other features, of course.
Which you'll need for A2.
Yeah,
so.
It's really nice. Then Thomas will talk about abstract classes. So this is also related to polymorphism. And then, we will talk briefly about UML diagrams and maybe have the command pattern example later on.
But why do we talk about UML? Well, so we decided to release homework 2 already today. So you have a bit more time to work on it. The deadline will be the same as in the semester schedule, so on the 16th of April. We just thought because you already know everything you need for homework 2, it's just you need to draw an UML diagram. That we will release it today. And then later on in the practicals, not at the end, but somewhere near the end, we'll talk a bit about UML diagrams, so you know how to complete homework 2, and we'll also do a short example.
So stay tuned, we will explain this later on. But now let's start with our first topic, and this is the most important one, so inheritance and polymorphism. And I think we directly start coding, right?
Yes.
So let's see, I have already prepared a bit. So we have a main, we have a user.hpp and an admin user. So we don't need the admin user right now, but I just want to implement very simple, without inheritance and any fancy stuff, a basic user. And in terms of user in some program. So what could be a user? I could have, for example, a username. So we have a username for him. And maybe we also have a password for the user that he can log into. So we probably do not store it in a safe way now, the password. We just store it as a string, but that's not the focus of today. Okay, so we have a username, a password, okay. And maybe we also write a constructor for the user. So we learned user, okay. Then the parameters, so maybe we pass the username and the password, make some initialization list where we initialize the username, where we initialize the password, and maybe we also write the print function for the user. That just prints the username and the password so that we have something to work on. So maybe we have some specific text prepared. Okay, welcome. Username. Maybe something like that, I don't know. Your secure password is, and we print the password, something like that. Okay, so we have a basic user class now, and maybe do you want to use my class?
Yeah, okay. So let's first create a user. Just user. Yeah, let's do it like this. So username. I know.
It will be me.
Yeah, now I have to type your password. So I guess you need to change it afterwards.
Everyone knows then.
And then let's also call the print method.
Yeah, maybe compile it and run it. But I hope so far everything is very familiar to you. Yeah, we run it. Okay, there is the message with my username and my password. Yeah, so this is really nice. Okay. But now, what if we want to do something more and we want to create an admin user? And now, I mean, I think an admin user is also a user, right? So because the user, we already wrote the class for the user, maybe it would be beneficial that we also relate the class admin user to the user class. And so I don't want to write the admin user class again with username password. Maybe I can reuse something of the user.
We need inheritance.
Okay, you have an idea for that.
Yeah, so I think you already heard, well, many things about inheritance. You're very far in the lecture. But just to recap, you have a base class, you have a subclass, and the subclass is just, somehow derived from that base class. Or if you want to express it in words, the subclass is a base class, which is different, for example, to composition. So if you just have a member variable, because, so with the examples here, we have that the admin user is a user, okay? And yeah, so what I want to say with composition, so here is it. In contrast to composition, the user has a password. So if you have a member variable, we have some like has a relation, because the user is not a password, but the user has a password. And with inheritance, we have this is a relation.
Okay, so let's implement this relation also in our program. Maybe I can do this even, yeah. So I want to specify now that the admin user is also a user, and I do this by writing a colon and then the class from where I want to inherit. So I write the user class here. And one important thing here is we need also to specify here whether it will be a public, private, or protected inheritance. I think it's just important that you know you will always write public here in our course and probably in most scenarios.
In other programming languages, most often this concept of different type of inheritance doesn't even exist. So we'll just use public with C++, but if you're interested and want to know what exactly the other types do, then I think the lecture covered all of them.
And this now means that the admin user is a user. So the admin user has now a username, and the admin user also has now a password. But maybe the admin user needs to be more secure, so maybe we add some features to it. So let's assume it also has a PIN code. Yeah, so maybe we should write private here again. So it has now a PIN code. Size is just an integer, a large enough integer. And maybe an admin user also has access to some very secure files. So let's say make a vector of strings that contain the file names of the secure files. Okay, maybe we need the vector here. Okay, and now I think we can write a constructor. So now we want to create an admin user. And what should be now the parameters? The parameters should be, of course, everything that is related to the original user.
So we still want to somehow specify the username and the password of an admin user.
So we get as parameters the username. We get as a parameter the password. And now additionally, we also want to set the PIN for the admin user. So size t, PIN. And yeah, of course, I mean, it would be now a nice thing to also initialize the secure files, but we will just hard code it now because it's not so important. Or maybe we say, aha, now the question is, how can we initialize username and password? Because if I do something like this, using the initializer list, this doesn't work because this member username is not accessible.
So I know, do we want to ask, does anyone have an idea how we now initialize the username and the password? Because we said our admin user is a user, so it should have a username and a password, but how do we initialize it?
Mm-hmm.
Yeah.
Mm-hmm.
So you can, here in the initializer list, in the first position, just call the constructor of the parent class.
Make it like this. And now we pass on the username and the password. And then we have still the pin to go. And it seems that it works. Yeah, very nice. Okay, so we created now the admin user here. And do we want to do something more?
The secure files.
The secure files should also be initialized. Yeah. I don't know. This is a vector, so maybe just input something. Do you have, maybe secret.txt, maybe passwords.txt. Yeah, so this maybe files that only the admin user can access. So just for demonstration. Okay, so with the constructor now, do we also write the method?
Yeah, we want to view the secret files if you're an admin user as well.
Okay, view secret files, no parameters, maybe const even. And maybe print the files first. So auto file in secure files. Maybe write this kind of in a list format, just the file name. I think this should suffice. And maybe we also want to write or print the name of the user first. So maybe something like hello username. I don't know. These are your files. Okay, so we just use the username here, and then we loop over it and print the files of the secure files. But it seems that it doesn't work here. So I just want to print the username, and the admin user is a user, so this should be possible. But why is it not possible right now? Yeah?
User, we need to change from private to protected.
Yeah.
So if we have this private specifier here in username, well, then this is really only in the user, because we know 3 specifiers: private, protected, and public. And the difference is that private is really only accessible in exactly this class that we are writing right now. And protected is also accessible in all subclasses. And because admin user is a subclass, we need this protected attribute so we can actually access the members of the user.
Okay, and there's a question.
If we use private in the user, but then could we use get username like as a getter in the admin user? Would that work the same as protected or?
Yeah, so if you have a private attribute and then you have a getter and setter, and this getter and setter could be then protected or public. So if this getter and setter is not private, then you can of course access it in the admin user and use this to get the username. Yeah.
So we do it like this, then this works. Yeah.
Is it better? Well, if it's better if you're at a getter or use protected, this just depends on your use case. I think it's fine if you do something like this, that you just make it protected, but if you have some additional logic around validation of usernames and you write a setter for it which validates usernames, you probably would want to make it private and then the setter protected. We could also try just making the get username protected.
Mm-hmm.
So now we can only get the username from the subclass and not from outside.
So if we just compile it, doesn't work.
You need to save the file.
Because I didn't save, okay. So this works, but if I want to write something like user.get username, then it does not work. Because now it's protected, and protected means just derived classes can access it. Okay, so now we've found several methods, but I just return it back to the original one that we have just protected on the attributes and directly access it here. And yeah, let's see whether it works. I mean, we didn't execute it at least.
No, and we did not create an admin user.
Oh, we did not even create an admin user, right?
Maybe I'll move this over like this.
Yeah, please do so.
Well, let's do something like this. And now, which did we include it? Oh, yeah, I need the pin.
Mm-hmm.
Yeah, something like this, because we need the username, the password, and for the admin user also the pin here in the constructor. So this is like the same as just creating any class now. We don't even know that this admin user is a user from just calling the constructor. But what we can see now is that on the admin user, we can actually call the print method. So we can see this here, as already suggested, we can call the print method even though the admin user has no print method and it's in the user. And we can call this now.
So we can basically call now all methods that are part of the user class as well as part of the admin user class.
Yeah, maybe also try part of the admin user class, few secret files. And yeah, let's try it. And yeah, the first user, then the admin user. So we printed just called the print method of the admin user, which does exactly the same as for the user. And then I can also call now few secret files because we have an admin user here.
Mm-hmm. This is working really nice. Okay, let's see. What do we want to do next? Okay, I mean, this is nice. So I just comment out your secret file. Okay, come on. So now we have the prints for me and for Julia. And of course, it's the same because both are users and we call the print method on the user.
But I think it would be nice if you also see my pin now, if you print an admin user.
So we want to write a print method that is specific for the admin user. So basically, I want to do something like this. I want to write here a print in the admin user and do something here. And basically the same function as in the user, but one more time in the admin user. So the first question is this possible? So can we write such a print function here? Or do we need to call it in another way? Print admin, for example. Who thinks that it is possible to do this? To write it like this, even though the function already exists in the user? Who thinks that it's not possible?
I think about 50-50. I think it was 3 versus 3.
Okay, and then 25 people, 30 people say they're not sure. Okay, indeed it is possible, we can do this. So we can write a specialized print function for the admin user. And I'm now lazy, I copy the first 2 lines of the user print function. So this should be the same. And then I add an additional line maybe your pin code, and we can access the pin, of course.
Can you also write welcome admin or something?
Welcome admin. Yeah. Just for sake of completeness, if we would do so in the user, then of course it doesn't work because the pin is not known to the user. Yeah, the user does not know whether there exists a pin or not. So this is really something specific for the admin user, and now we have the print function also here. Okay.
So we here have now the admin.print and the user.print. Maybe let's try it again. Who thinks that this admin.print here now really calls this admin method here? Who thinks now that still the user print method is called? I think now 3 were for the user method and 2 for the admin method. So
let's try it out, I would say.
But yeah, it seems to work. Maybe we can indent this so we can see it better. But we can actually see that here we have welcome admin, and also a pin code is printed. So we actually call the method of the admin user. Maybe I'll do something like this.
Make it more clear, yeah.
Yeah, now we actually see, okay, we are calling the print method of the admin user.
So like C++ automatically knows, okay, we have an admin user here, and for that reason we use the print method of the admin user and not just of the user, because the admin is more specific.
But, yeah. No. So, yeah, we did this. Now I want to talk about something that also C++ does for us when it comes to these base and subclasses. Namely, we can cast subclasses into pointer or references of base classes. And this also works implicitly, so we don't need to explicitly write it. So for example...
So this means we don't need to write like, I want to cast it into something, it works directly.
Yes, we can just, it just works like passing an integer to a function which expects a double, then you don't need to cast it, it just works like this implicitly. And for example, now the admin user pointer can be cast to a user pointer, or the admin user reference can be cast to a user reference.
Note that we cannot create an admin user object and store it in the user, because this doesn't work. Because I mean, then the user has some memory available for the 2 strings, and the admin user would need to have the additional memory for the pin. So this cannot work. But if we have a pointer, then we could say we interpret this memory as an admin user, or we interpret this part of the memory as a normal user.
So something like this wouldn't really work.
Yeah, exactly.
But what does work, if we already have an admin user, then we can create a user pointer, maybe call it admin pointer, and point it to the admin. We can compile it and check, and no errors.
What is this and before the admin? Maybe for those who did not take ESB, it just takes the address of the variable admin.
Yeah, and the same thing works with a reference. So now we are not copying the admin into the user object, but we actually have a user reference here, which references the admin.
And like really in both cases, this just means, okay, there is this memory part, and we interpret this memory now as a user. And this is possible because an admin user is a user. So we kind of forget about that it's also an admin user. It's just a user for us anymore.
Well, and if you forget about it being an admin user, if I have these admin references and try to use few secure files or something.
I think it was secret files.
Yeah. Okay. then it does not work. We can also try to compile it. Well, it now thinks this is just a user because it's a user reference. And yeah, we can't call view secret files on a user reference because it references a user and it does not know that it actually is an admin user.
But what if we try the print function now?
Yeah, we could try that. So if you do it like admin references.print, do we want to ask again what happens?
So now we have the user reference here. We call the print function. And now print, it seems to work at least because, I mean, print is also a function of the user. But now the question is, will the user function be called, so where the pin is not printed, or will the admin user function be called? Who is for the user function without the code?
Oh, many now.
Yeah, and who is for the admin user function? A few people also for the admin, most for the users. Try it out.
And so we have 3 prints. The first one is this, the second one is this, and then the third one, and the last one, we can see, okay, now apparently the user print is called, and yeah, and because we see only the password, we do not see the pin, and also this admin here is missing. So is there anything we can do about this? Because this is probably not what we want. So if we already store some pointer or reference to a user, we probably always want to call the correct print method. We never want to call the wrong one.
So is there a possibility now?
And yes, you heard it already in the lecture. This is what polymorphism is actually about, because we have this problem where we will have different kinds of users, but always want to call the correct print method. And so, yeah, this is what I just said. And the solution, you already seen it, virtual functions. This just works by writing virtual before the function in the base class. So the compiler knows, okay, this function I should look up at runtime which function actually calls. So it constructs this v table in the base class. And then we also need to do the override in the subclass, or we don't need to do it. It's optional, but we should do it because then we really know if we have really overwritten this function.
And you need to do it because we will grade this also. So always write override here. Okay, and then let's try to fix that. And it's just writing virtual in front of the print function of the user. So it's just important for the base class. And in the derived class, we will write here override to indicate, okay, there must be a function in the base class that we want to override. If I would write override here, then it doesn't work because there is no view secret file function in the user.
So this might help catch typos if we accidentally misspelled print and then wondered why the wrong function is called. If we specify override, then it tells us, okay, this function does not exist and you can't override it.
And now this depends now again on the use case, but if you plan to also derive the admin user class at some point, because you say there is the super admin user, and it is even an admin user and the user, but can also do more things. In this case, we would also need to write virtual here, and we can also generally write it here because it doesn't affect it in a bad way. But this is not needed at all, and this is also optional, but this is required. We can leave this out now because we don't want to derive admin user one more time. Okay, I hope we have fixed it now with that. Maybe let's try one more time.
And yeah, it seems to work. We have these admin references. We want to call print, and it actually calls the print method of the admin user.
I think this is really nice now because really the admin reference is now taken here, and now the C++ more or less asks, okay, yeah, admin reference, we have this pointer. Okay, where was this class created? Oh, it was created as an admin user. okay, then I need to look up, is there a specific print function for the admin user instead of just the normal one? Oh, yes, this exists. Now I call this function. So this is really nice that this works and this can be implemented in that way.
Yeah, but now let's pretend we only have the admin reference. So we just get this user reference. For example, we are in some function where we only get the reference to a user. But now we know, for example, that this is an admin user, and we want to call the view secret files. And as we have seen before, this does not work. Even though it now calls the correct print function, it's still a user reference. So in the first place, we do not know if this even is an admin user. It could be some different user. And therefore, we can't just call it on this admin reference.
So in this case, unfortunately, C++ does not see, okay, yeah, this was an admin user, and now I look those functions up, and I call the right one. So this is...
And for example, if you're in a function, we do not know even if the user at runtime is an admin user or a normal user. And then the compiler can tell if you are allowed to call this function or not, because there could be multiple times in our program where we call this function, and sometimes it is an admin user and sometimes it is not. So we actually need to handle this in some way.
Yeah, so how can we call it?
Yeah, and now we come to the second kind of casts. You did not really see this in the lecture yet, but you'll learn more about those casts later in 2 weeks. Next week?
Next week, maybe, if they have time.
So there exists something called a dynamic cast, where you can cast from some base class reference or pointer to a subclass. So, for example, in our case, you can cast a user pointer to an admin user or the reference. And what I said before, this must check at runtime if you can actually do this cast. Because if you want to cast a user to an admin user, but this user is not actually an admin user, then it somehow needs to fail.
So if you maybe open the code, so at the very beginning, you created me, as a user here, and of course I can never be casted into an admin user because I'm not an admin user, so this should not be possible.
Yeah. So if our user is not actually an admin user, then this dynamic cast returns a null pointer if we try to cast a pointer, or throws an exception if we try to cast a reference.
So kind of an expected behavior there.
Yeah. So how do we use this now? Or how does this work? Well, pretend again we only have this user reference here. And now we want to get an admin user reference. So, I don't know. Let's call it admin reference 2. And now we can do this dynamic cast. And this is now similar to how you've seen it in a vector, where in these angled brackets here you specify which type you want to cast it to, and we want to cast it to an admin user reference. And in here, we specify the admin ref. And this now should be possible, right?
So maybe we run the code.
Or compile it because I do not see anything.
It compiles. And now you claim that we can also call the secret file. Okay, so this also seems to work. So what we did here, basically, we first created the admin user Julia, then we casted it into a user here, and then we again tried to cast it back to an admin user reference here. And since Julia is an admin user, this also works, and we can call the view secret files function on Julia. Okay, now let's see what happens if I want to be an admin user. So I'm just the user here, and basically I can just write myself into here. I want to be now an admin user reference. Admin user reference 2, works. Admin user reference to view secret files. VS Code doesn't underline it, so it will work.
You need to save it.
I need to save it. Yeah. And I can compile. Yeah, this works. This is nice. So now I can view the secret files. And maybe let's run it. And yeah, I'm not allowed to do that, unfortunately. So here we have what you said before. We have now an exception. So I think you should already know what this is. So it's a standard bad cast exception. And it tells us, something? No, it just tells us that the cast did not work here. Now, I mean, we would need to figure out which cast didn't work if we have multiple in our program, but apparently this is, of course, this cast here, and it's not possible because I'm not an admin. So,
yeah, but we also learned that we shouldn't use exceptions in normal program flow. And now if our function wants to differentiate 5 types of users, and for every user we need to catch an exception, just so we know that this is not the correct user, this would be somehow normal program flow which we handle with exceptions, and therefore maybe let's try it with pointer.
Okay, so maybe make it, switch the keyword layout, maybe make it a pointer. And now we want to cast in the pointer. Now we write maybe let's do it with u first. So we make a admin, we take the admin pointer in this case. So we take the admin pointer, try to cast it back here. Then if we want to call something on it, we need dereferenciation. And we have here also the pointer. So a dereferenciation and then going to the corresponding method.
You need to save.
I need to, yeah, okay. And yeah, this works for you. Mm-hmm. Now I pretend that I'm an admin user again. So I now need to hand in my address because we're dealing with pointers here. And I did not save. Yeah. Okay, and now we get something even worse. We get now a segmentation fault instead of the exception. And we can just fix it because if we check whether the admin pointer 2 equals a null pointer. So if it's a null pointer and we try to dereference it, then we would get the segmentation fault. But if we check it and see, oh, it's a null pointer, then maybe you do not have permission. So in this case, we cannot do it. And in the other case, it should be possible. Maybe clean this up a bit. So, and what happens now? Now, yeah, if I try to do that on me, then I do not have permission. So we have a null pointer. I cannot do this, and we do not call this function.
Maybe try with admin again. I don't know. Just so we see that this if now works.
Yeah, so we cast the Julia. This works. Yeah. Okay, so we know now basically, or we have seen how that if we have a derived class, then we can immediately defer the base class of it. But in the reverse direction, we really need to check whether this is possible because this is not guaranteed, because not every user is an admin user. Okay. Any questions regarding the cast?
So this was actually something new we did today.
Yeah.
There will be more new things today.
So we have one last tiny little bit, right? So let's get
rid of everything.
Get rid of everything. Okay, I will do. Maybe now this is not really related to what we've done before, but we just add it here because it fits nicely. Maybe we have here some additional attribute, I don't know, an integer pointer, which does something, I don't know, it doesn't really matter. And then this is in the attributes of the admin user, so we also modify the constructor. So we write an initialization of one more thing, the pointer, maybe make new int, I don't know, 42. Okay, so we create the integer. Now we also have to think about the destructor because we need to free the memory. Okay, so we have no destructor yet, so maybe write an admin user destructor, so the tilde in front, and just delete the pointer. Okay, so whenever the constructor is called, we allocate it. When the destructor is called, we delete it. What do we need to do now? What do we have seen last time, which we have to think about now? If we have
the last practicals.
Last practicals. If we need to implement the destructor, what else do we need to implement then? Yeah.
No, in the last practicals.
So, yeah, but yeah, we need to think about this later on. Yeah.
Yeah. Yes.
Yeah. Whenever we implement the destructor, we also need to think about the copy constructor. So I didn't want to do this, but I will do this now explicitly, since nearly nobody remembered that. So this is the const admin user reference. I will set it to delete now so that nobody can use it. Either I implement it explicitly or just delete it that I cannot use it. Okay.
Should I try it out?
Yeah, try it out whether this now works.
Well, okay, maybe let's just create an admin user first. I'll let you be the admin user.
Now I am the admin, yes.
So something like this, we've seen this before. Compile it, run it with Valgrind, and yeah, everything seems to work.
Yes, 0 errors here, yeah, so looks nice.
But it's actually not quite correct, because what if we try now to make something like this? So we create a new admin user on the heap. And now,
Yeah.
oh yeah, we have some. We can scroll up. We didn't. Okay, we had 0 bytes in use at exit before.
But I can't follow. Make it a bit larger and maybe step by step. Okay.
So we didn't see this before, but now we have 12 bytes, 180 bytes in use at exit. So we leaked memory, and here we actually had 0 bytes in use at exit. So before it worked.
Maybe we can also run Valgrind with the -- leak check equals full, which states here to see this a bit better. And now it also really indicates it as to be an error here. Yeah.
Yeah, and you can also see that this happened in the main function.
Yeah. Maybe we ask.
Yeah. So. Yeah, does anyone have an idea why it worked if we just created the admin user normally, but now if we create it on the heap, we actually get some memory leaks?
Mm-hmm.
Yeah, it's never freed. Do you also know why why the destructor is not called if we do new admin user? But
yeah.
Oh yeah, sorry. Something like this. Yeah.
Exactly. Now we call delete.
Mm-hmm.
Yeah. 0 errors. Very fine solution. Yeah. Okay. So this works now. Okay.
But already one step ahead. Sorry.
You forgot about the delete. Okay. Maybe we don't want to store me now as an admin user in an admin user pointer, because we said before we can just store me also as a user pointer. And okay, we do the same as before and we call delete now. Oh, should work, but now we have again errors. But we didn't change it, like we just changed the user pointer to an admin user pointer. But now we get memory leaks. Why is that? I mean, we can show we have here a destructor. It should free the pointer at some point. Also, this thing here is freed, so.
Yeah.
Maybe allocated only in the user, but it's never freed in the user?
No. So the answer was, is it also allocated in the user? And if you mean the admin, if you mean in the admin user, this pointer is really only allocated here in the admin user. So if you want to, actually delete it in the user, so if you write a destructor now.
Now with a tilde, yeah. Oops.
If you write a destructor now, we actually can't delete this pointer because you cannot access it because the pointer is in the admin user.
Yeah, so this doesn't exist here.
Does anyone have another idea or maybe a solution?
I will try something now. Okay, maybe we said we implemented the destructor here, and we did not implement the destructor here because we didn't need it. No, I just write the destructor in the user, which doesn't do anything because nothing has to be done. Try it out, maybe. Maybe this is better. Still the 3 errors. Anyone an idea? Yeah? Yeah?
I think the destructor is not virtual, so it can replace it in the V table.
Yeah, this is correct. Yeah, so the destructor is not virtual. So
what we have seen before, if you remember with the print function, if we have a pointer, a user pointer to an admin user, and we do not write virtual, so before we actually introduce polymorphism today, we call the print function of the user class. And the same thing happens with the destructor. If we have a user pointer here and delete it, we just call the destructor of the user. But what we need to actually free our memory is that the destructor of the admin user is called, because it's actually an admin user, our user pointer.
okay, and yeah, as you said, the solution is then just writing virtual in front here. And if we do so, and compile and run it again, then the errors are gone. Maybe we can also just visualize this a bit here. So I'll just write, user here, and I will also print something here, admin user. And if I remove the virtual, then we really have, or it's really the case that only the destructor of user is called. But if we write virtual here, then again it checks, is there a destructor also for some subclass? Oh, we were an admin user. Okay, we need to call this destructor. And then, as also it can be seen here, first the admin user part of the user is destructed, so the additional part, and then the remaining user part is destructed. So they are called in this way.
It works exactly the same as before. And if you do not understand this now with the destructor, maybe afterwards you can watch the recording about how we did it with the print method, because it's actually the exact same concept. If we call a function on some object that we have, then it needs to be virtual if we actually want to call the correct function if we have a pointer to a base class. And this also holds for the destructor.
Okay, I think it was everything here. Do you have any questions now regarding this example? Should we try something? But I think we have at least seen everything that may occur.
Yeah, we tried to somehow do everything with inheritance and polymorphism that could happen to you when implementing it on your own. Yeah.
Okay, otherwise, well, we will now move on to the STD map and with our first special guest of today, with Daniel.
Hello.
Yeah. Sorry.
Okay. So, hello. Some of you might know me from ESP, and this is my first time actually holding sort of a lecture in the practicals here. So I'm glad to introduce you to STD map. You already know STD vector, and this is pretty similar. Let me first tell you a story from correcting ESP last semester or the previous year. One of my students actually used an array and used characters as the indices because it was convenient. But this led to him creating a really, really large array, which he didn't need, because he only used the indices which actually mapped to the SC values of the characters he used. But this concept is exactly what STD map implements. So let's see how this works. What is STD map? Well, this is just a collection of key value pairs. So the first thing we need to understand is what is a key value pair and how is this implemented in C++. So for this, we have STD pair, and this just stores a pair of values. A pair of values, you can imagine just two values of two different potential types. And these types you just pass like you do with STD vector, but since you now have two types, you need the comma in between. So in this case, our types are integer and STD string. And we just construct a pair here with 404, an integer, and not found a string. And then we just print it, and we use .first and .second to get the first and second member variable respectively of the pair. So when we run this, we get the expected output, first the integer and then the string.
Yeah. So actually what we have here is now, we talked about key value pairs before, but these pairs also can be used without using a map, just to store two different types, two different values in this pair.
What we should mention here is that this is included in utility, and STD map is actually in map included. So if you want to just use the map, you only have to include map.
Yeah.
Okay, so now we can continue with what STD map actually is. We already know it stores key value pairs, and now we tell you that it's a mapping from keys to values.
Yeah, and if you think about the pair from before, you can think about the first that we have seen as the key, and the second one as the value.
So what STD map actually does for you is actually it creates sort of a pick your own index vector. So you use the keys to access the values, and in this case the keys must be unique, like an index is unique in a vector. For example, if you want to access the first element of a vector, you would use the index 0. And in this case, you can just use, for example, an arbitrary integer or even a string or any other type you can use as a key to access a specific value within the map, given that this key value pair actually exists within the map. But we will get to that later. Okay, so the values can be just chosen arbitrarily. You just have to insert the correct key value pair. And every key is associated with exactly one value. And you may have already heard the name associative array or even dictionary from other programming languages, and this is basically the same thing.
Yeah, and you can also think about this map like, as the name implies, as a mapping from a key to a value, or if you want to think about more mathematically about it, like a function where you input some value and then get some output.
Okay, so here we have the first example. I do not need to run this because this won't output anything. But as you can see here, we construct a STD map. We also give two types. Again, the first type refers to the key and the second type to the value. So we now can just pass a list of key value pairs we already want to insert by default into this map. And we just insert here 2 key value pairs.
Maybe there's also something new here that you haven't seen up until
yeah.
now. You can omit the name of the constructor if the type is already known. So you can see here that inside, by constructing this map, you do not need to write std pair and then call the constructor with 404 and not found, but we can just write these curly braces to automatically call the right constructor, because C++ knows this needs to be a pair that we pass in here.
A pair with these 2 types, because it knows that already from the map, so it doesn't need to know it again. Okay, let's continue. What the first thing is we can do with a map when we have it is, of course, getting an element. Accessing an element is just like with vector, you use the method .add. So now we can just use any key which is in the map to get any value associated with that key. So in this case, we get internal server error, which in this case is good because that's actually in the map. Otherwise, that would be bad. Okay. One second thing I would like to mention is that you can also use the square brackets to access elements within the map, just like you do in C with arrays, or you could theoretically do with a vector also. But I would advise against this, and you should use add, the method instead, because add actually does bound checks, and this operator does not. And also, if I were to use any key that isn't actually contained within this map, add would throw an exception, and this operator would insert a default constructed value at that key. So it would extend my map, which in this case I don't want to if I just would like to read this value.
Yeah, so if you think about the vector, the first thing is that this add method really does the check. Same with the vector, if you do .add on a vector, it really checks, does this element actually exist? And here with this map, these square brackets do something even worse than with the vector, because in the vector we might crash, and we see that we crash and can fix it, but here it actually, if you just do it like this and it does not exist, it just creates a new element in that map with this key, so we don't even know that it wasn't actually in the map, and might even think that we inserted it before, even though we just created it.
And we could cause trouble if the element isn't default constructible. Okay, so now the next point is how do I actually insert something into the map so I extend the map by choice and not by accident like we have just seen. So you already know how to make a map, and you already know how to create a pair. And there's just this conveniently named method insert to insert a pair into the map. Pretty easy, right? But as you have seen here in the constructor of the map, we can already also omit this pair define because the map already knows the types and can create this for us.
Yeah, and this also works with any function. If we just want to construct some object, when we pass it to a function, we can actually omit the name of the constructor and just do it like this, because C++ knows insert expects a pair, and we can just call the constructor of the pair like this.
But there's even one better way to do this, the way I don't even have to write the curly brackets, namely the method mPlace, which constructs the pair for you in place and inserts it directly into the map. Okay, so we have already seen how to insert something. Now we would like to know how to iterate over the map. This is pretty similar to vector, and you also can use these range-based for loops to iterate over the pairs of the map. So this is where you can now get into this variable, you get the pair, so you actually have to use first and second if you want to access the integer and strings in this map, respectively. And this is kind of confusing, because now you have .first, .second, which could be kind of unintuitive if somebody else would read your code. So we actually want to give that a better name.
Yeah.
And we could do that by just initializing a new variable at the beginning of the loop, but that's kind of stupid, and C++ has a nice feature for that. Namely, we can sort of unpack our pair into 2 distinct values and variables using the square brackets here. So you might know that from, for example, Python or some other programming languages, which also have some feature like a dictionary implemented, where you can also do this.
So
and
if you think about the map like...
output is the exact same.
Yeah, so if you think about this map like a vector which contains pairs, then the previous method would just
That's
be
the
like
exact same thing.
iterating over this vector, and then we can access the first and second element of the pair. But we often don't want this because first and second are bad names if we actually want to know what happens. And yeah, therefore we can use these square brackets, and then the first is automatically placed in the status code and the second one in a reason phrase.
Okay, now how do we actually find a key value pair in this map if we don't know if it even is in map? There's again a conveniently named method named find, which you can pass a key to, and this gives you an iterator. Well, I think you may not know already what an iterator is, but you will learn that later. For now, you can just think of it as sort of a pointer to a key value pair which you could dereference to get your key and value, with which you can work. And if the key isn't contained within the map, then you will get map.end. Map in this case really refers to the name of an instance and not to the class. So you would have, for example, if we have this example, you would have a status map.end.
Yeah.
Okay.
And this return value of the end, you can just think of it as some invalid value that you would get from find. So if you think about it like pointers, you could, for example, think about it like map.end returns the null pointer. But it is important that you use map.end because it's not actually a pointer.
Exactly. And now the last thing is if you want to check for containment. Does somebody want to guess the name of the method which you can use here?
So if we want to check if some key is in a map,
it was pretty easy up until now. It's just contains, sorry. Contains key returns true or false, just a Boolean value, whether the key is actually contained in the map or not. But there's one catch. This is only available upwards from C++ 20. And in the practicals, we use C++ 17. So, yeah.
Yeah, at least for assignment 1.
Exactly. But I will get to that. You ruined the surprise.
Oh, sorry.
No, doesn't matter. Okay. But as you have seen on the previous slide, map.find returns map.end if the key isn't contained in the map, and you can just check for that. Or there's the method count key that returns the amount of times the key is actually contained in the map. And like we said before, in this case, keys are unique, so it's either 1 or 0, depending if it's in the map or not. And like Julia already said, starting with A2, we will start using C++ 20, so I kind of wasted your time by telling you this, and you can just use contains. Okay,
yeah.
So now I would like, if you have nothing against it, and then I will start doing the example. I have come to hear that it was asked how to map enumerator of an enum class to a string. And I thought that would be a pretty easy example to show you, and it would be sensible to use, for example, for error codes and error messages, like you've already seen on the slides, but now with an enum class enumerator as the key and not actually an integer. So the first thing I would like to do is, of course, create our enum class. In this example, I would like to map grades, so A to E, to their respective names. In this case, this is just a translation of the Austrian grading system. So we'll create a grade enum class. And we will insert A to E into this enum class. Do we need, besides the semicolon, anything else in here? Yeah, actually, yes. I would like to have one additional value for ungraded students that haven't yet received a grade, because if I want to store a grade, for example, in a student class, and I would like to track their grade for a given course, then I would also have to have some kind of initial value when the student hasn't yet received any grade. Okay, then
enum classes, I think we did in the first practicals that we held this semester. There, I think we've shown you an enum class with an ingredient class where we made some units with an enum class.
Okay, now I can actually start implementing our map. I've already included map. If you haven't seen that on the slides before, this you have to do to use std map. And now I can just use map and give it 2 types. So the types I would like to pass is the key and the value. And in this case, the key should be our new defined grade type. And the name should be stored in a std string. So I will use string. Now, the collection name should be something that indicates what I will get out of the map when I give it a key. So in this case, I get a grade name, so it might be a good idea to call this grade names. And I already want to insert some values. In this case, I would like to insert A, and because I'm lazy, I will do this. And B, and of course, C to E. Okay. And because sometimes this is asked on Discord, how do I not make typos from the messages? You just copy the messages. So I will do that now, because I'm actually lazy and because this is convenient.
So this actually solves a problem that I think we had with a question before. If we have an enum class, is there some way to get the string representation of its members if you want to print it? And the answer is still no, but we can create something like this map here where we write the strings ourselves.
Okay, now I would like to print your current grade. So your current OOP1 grade should be, of course, ungraded because the course isn't over yet, of course. So now I will do grade names, and I will intentionally use this operator here with the square brackets to show you what I was talking about before.
Yeah, so note that ungraded, we did not insert ungraded in the map.
Exactly.
above.
So this is not yet in the map. And now I would just iterate over the map keys and values and just output them. So I will use const auto reference, and I want to unpack those. I will get the first is the key, so the grade, and the second is the name. So I will write grade, comma, and the name. And of course, I will iterate over grade names. And now in this loop, I can output sort of a list. So I will prefix this, and I will output the name. Okay. So now I will just compile. I could use my shortcut, but actually...
Did you save the file?
I did not, thank you. As you can see, this is a common mistake, so okay. And I will already would like to run this afterwards, so I will do this. Okay, and as you can see now, we have our list, but there is one empty value, which coincidentally corresponds to the place of our ungraded in our enum class. So as you can see here, our use of the operator actually caused this. So if I were to comment out this line and do this again, then you will see the map is as we specified. So how could I now get rid of this? Because this is kind of annoying.
Yeah, so maybe just what we see now is that we used the square brackets and actually did not get any error because the print message was just empty. And then afterwards we observed that now in our map is this extra empty dash or entry, which we also printed,
Exactly.
and that's not what we want.
We have just a default constructed string, so an empty string, and that's, yeah, we don't want it. So I would like to show you something that wasn't on the slides, actually how to delete something out of the map. So in this case, I would like to delete our ungraded again. So now we should have the same output. If I save the file, yes, I did. Okay, so now we have the same output again. But actually, I'm not really a fan of that. So let's insert really some value for our ungraded. How do I do that? Which methods could I use to insert a value? Does anybody want to tell me? No? Okay, then I will pick one and I will use mplace. So I will do grade names and I will use mplace and just pass. In this case, I don't need any curly brackets. I can just pass the enum as the key, the enumerator as the key, and any string. So I will just say ungraded, and this should be it. And now we should have a value at this place in the map. Okay, but now I would like to somehow change something up in the map. So we already have seen that the add method returns a reference. So I can also use this to actually modify our values. And I will do that and set add grade A equal to the string awesome. Okay, so this shouldn't change anything yet because we didn't print that. But as I would also like to give you guys a grade today, I will give you your grade for the day, which will be grade names at grade A. Almost. Okay. And as you can see now, we have modified the map, and now our element, our string at the key grade A is now awesome. Okay, so I think I'm done for the example.
Yeah.
Are there any questions to this? I think that's a pretty easy concept. Once you've understood STD vector, I think you're already there.
Yeah, I mean, it could be overwhelming at first, but if you actually try to use it on your own, I think you should have an idea of what it does pretty quickly. And I think we have seen now everything that we want to do with a map. We inserted some elements. We have seen why we shouldn't use these square brackets to access it. And we've also seen how to delete something. Yes?
So if we switch in this example grade and STD string around, we can also access the
Exactly. You could, for example, even iterate over this map and build up a second map in the reverse order, so you could have a reverse mapping. Then this would also solve sort of code duplication, because now you only have to build one map and create the other one from the first one.
Yeah, so we can actually do the string as the first element in the pair and the grade as the second, and then we could, for example, map the satisfactory grade to grade C, so the actual enum type from the string. For example, could be used in user input or something. Okay. I think if there are no more questions, how long do we want to make the break? Or do we want to make the break yet? 10 minutes? Okay, so at 70:22, do you want to say before I start the break?
Just thank you for being here, for allowing me to be here. It was really fun. So I hope you guys learned something interesting, and yeah, maybe we'll see each other again in the assignment interviews.
Yeah. So then we'll make a break. After the break, we will talk about abstract classes, and now we'll do the break until 17:23. If you have any more questions, you can also come down here in the break if you want. Okay, then until in 10 minutes.